Hello everyone, so today we're going to go over the Unit 4 practice test, starting with the multiple choice questions. Question number 1. So to divide this polynomial by the binomial x plus 3, we will be using synthetic division. So let's set it up here. On the left-hand side of the bar, we have negative 3. Since x plus 3 is the same as x minus negative 3. Next, we'll list the coefficient in descending order. So 3, 3, 4, and then negative 3. Okay, so the first 3 gets carried down. And then we have negative 3 times 3, which is negative 9. And then we take the sum of 3 plus negative 9, which is negative 6. And then we have a product of negative 3 times negative 6, which is, of course, 18. 4 plus 18 is 22. And then, again, the product, negative 3 times 22 is negative 66. So this last number will be the sum of negative 69. So once we've done that, we have the quotient 3x cubed minus 6x squared plus 22, and the remainder is negative 69. So the choice is C. Okay. Number 2. What is the remainder? So instead of dividing here, we can simply use the remainder theorem. So once again, we have x plus 4 is the same as x minus negative 4. So we'll substitute negative 4 into the polynomial. So here we have negative 4 cubed plus, to the 4th power, plus negative 4 cubed minus 7 times negative 4 squared minus 2 times negative 4, and then plus 5. Okay, so we have 256, and then minus 64, minus 7 times 16 here, plus 8, and then plus 5. Let's continue simplifying here. So we have 256 minus 64, and then minus 112 plus 8, and then plus 5. So altogether, the sum and difference, this will be 93. So the choice is A. Moving on to number 3. Which one of these statements are always true? Okay, so the first statement, the degree of the remainder is less than that of the divisor. That is always true by the definition of polynomial division. Second one, as we saw earlier, synthetic division, the variables are removed and only the coefficients are recorded, so that's true. The coefficients are listed in descending order and not ascending order, so C is false. Sorry, number 3 is false. And then the product of the constant terms of the divisor and quotient equals the constant term of the dividend. That is not always true. If there's a remainder with a constant term, then that statement is not true. So number 3, the choice is C. Okay, let's move on to number 4. Which polynomial has x plus 3 as a factor? So we could substitute in negative 3 into each one of the 4 polynomials and find out which one of them is equal to 0, and that will be the the one that has x plus 3 as a factor. Alternatively, we can just look at the constant terms of each one of these polynomials. The one that has 3 as a factor will be the answer because of the integral zero theorem. So as we can see here, this one has 0 as a constant, so that is not it. 37 is a prime number, so that's not it either. Here again, 0 is the constant, so that's not it. So the only choice that makes sense is D. And of course, 111 is divisible by 3. And we can also check by substituting -3 into the expression here to make sure that it is indeed a factor. Okay, so this is -27, and then minus 81 minus 3 plus 111, and that is equal to 0. So yeah, so the correct choice is D. Number 5, which binomial is a factor of the polynomial? So this time around, we cannot just rely on the integral zero theorem, although it will eliminate D as one of the choices, since 5 is not a factor of 6. So here what we can do is to substitute in, for A, we'll substitute in -3, for B, we'll try 3, and for C, we'll try the number 6. And so let's say, for example, we try 3 and substitute it into the polynomial. And let's see here, we have 27 times 2, which is 54, and then minus 63, plus 15 minus 6. So that is equal to 0. So x minus 3 must be a factor, so the answer here is B. Moving on to number 6. Which integer values of A should be chosen to test for binomial factors? So again, another integral zero theorem question. So since the constant term here is 9, we're just looking at the positive and negative factors of 9. So that will be positive or -1, positive or -3, and also positive or -9. So the choice is D. Okay, number 7. Right, so we have a polynomial with one unknown coefficient, q, and it is divided by x minus 3, and the remainder is 4. What's the value of q? So this is just an application of the remainder theorem. So we will set 4 is equal to, and then the polynomial with 3 substituted in, plus q times 3 squared, then plus 11 times 3 minus 20. So we can simplify this. 3 cubed is 27. 27 times 4 is 108. And then we have 9q plus 33 minus 20. So if we move the constants to the left-hand side, we'll have -117 is equal to 9q. So q must be equal to -13. So in this answer is B. Okay, let's move on to number 8. Type of polynomial. So this time we're just looking at the highest power of x, it is 5, so it is quintic. Number 9. So which statement is always true for both graphs of cubic functions and graphs of quintic functions? So this will be degree 3 and 5 respectively. Odd number of x-intercepts, that is not always true. It is possible, for example, for a cubic function to have a x-intercept of multiplicity 1 and then another x-intercept of multiplicity 2. So that's only 2 x-intercepts. The graphs never have the equal numbers of hills and valleys. It is possible to draw something that has, for example, cubic function could look like this. This will be one local maximum and one local minimum. So that's an equal number of hills and valleys. So that means this one is also false. The constant term is the y-intercept. That's always true. If we just let x equal 0, then the constant term should be all that remains in the polynomial, and that will be the y-intercept. Let's see. When the terms of the greatest degree in the equation are negative, the graph rises to the left and falls to the right. So that's true. As we know, odd degree polynomials that are negative comes from quadrant 2 to the left and then moves to quadrant 4 to the right. So that will match statement number 4. So the correct answer here is that statements 3 and 4 are correct. So the choice is A. Okay, let's move on to number 10. The graph of a polynomial function of degree 4 is shown. Which statements are true? Well, degree 4 is even, so that's true. And then, actually just scroll down, there we go. Has a 0 of multiplicity 2 right here. So that's true. So the multiplicities are 2 and then 1 and 1, which adds up to 4. Equation of function has negative leading coefficient. That is not true. If it was negative, it will be upside down. The y-intercept is positive. That is true. As we can see here, it is above the x-axis. So the statements that are true are 1, 2, and 4. So the correct choice here is D. Okay, moving on to number 11. Determine the zeros of the polynomial function x cubed plus x squared minus 12x. So here we can factor out the x, and then we have x squared plus x minus 12, and of course that can be factored, so we have x plus 4, x minus 3. So then the zeros are x equal to 0, negative 4, and 3. So the correct choice this time is B. Okay, number 12. So we're looking for the graph of x cubed plus 4x squared plus 5x plus 2. So of these 4 graphs, only A is odd degreed and positive and has the correct y-intercept. So 12 must be A. And finally, number 13. See here, a piece of cardboard 30 by 16 is used to make a box with a top. Okay, so it's a net diagram. Right, so what is the volume? So this one, we know that volume is equal to length times width times height. So if we were to look at the box, we'll have the following, and that is, on this one side, this side here, if we just look at this side, which will be either the length or the width of the box. This side here will be 16 minus 2x. And then a second side, this side here, would be 15 minus x. And finally, the height of the box will just be the variable x. Okay, so the three sides of the box are 16 minus 2x, and then 15 minus x, and finally x. So we can factor out the 2 from the first set of parentheses. So we have 2 times 8 minus x, and then 15 minus x, and then x, which means the correct choice here is A. So that is all of the multiple choice question. There will be a second part where we go over the problems. So thank you for listening.